Hello everybody, my name is Hello. Welcome back to this series where we're solving Codeforces problems in Python. We're doing the A to OJ ladder, and in this episode we're going to be solving problem 214a, which is called system of equations. Now this is a bit of a tricky problem, maybe because there's a bit of math involved with but nevertheless it's one of the easier problems. Let's go ahead and see how we can solve this. Let's go ahead and read through this problem now. Furik loves math lessons very much, so he doesn't attend them, unlike Rubik. Now Furik wants to get a good mark for math. For that, Miss Ivanova, his math teacher, gave him a new task. Furik solved the task immediately. Can you? Okay. So you're given a system of equations, which is this: a square plus b equal to n, a plus b square is equal to m. Now, you should count how many pairs of integers a comma b satisfy this system of equations where a and b are greater than equal to 0. Okay. Now, what is given to us is n and m. Using that, we have to count how many integers or pair of integers solve this system of equation. Okay, that's it. So we will be given what n and m are. Then we have to go ahead and solve what are the possible values for a and b, and then count the number of such values and print this to the user. How do you solve this? Is it looking a bit tricky? Yes. Okay, let's kind of demystify a lot of this because then it'll make much more sense, I swear. Okay, now something to keep in mind is the inputs for a, n and m. Now looking at this, right, this is going to be a brute force approach. Okay, but our goal here would be to not brute force the entire thing. So first of all, let's find out what the limits are for a and b. Okay, so first of all, okay, I'm going to take the system of equations here, which will be a square plus b given by n, and then a plus b square, which will be given by m. Okay, I am going to assume one equation. Okay, now we already do know that 0 is lesser than or equal to a and b, but we don't know what a or b is less than or equal to. Okay, so what I'm going to do here is I am going to apply b is equal to 0, because at the minimum b will be 0, correct? So what I'll do, I'll apply b is equal to 0 in this equation right here. That'll give me a square is equal to n, correct? Now what will be a's value? A's value in this case will be square root of n, correct? So again, I can, in the same equation, I can apply a is equal to 0. In that case, what will happen? B will be equal to n. Make sense? Now, a can be 0 to n because we obviously know this root of n is definitely greater than 0. And we know that the maximum limit for a here will be square root of n. Therefore, the values of a, I can say, will be up to square root of n. This is something that we need. Now, we can either take a, you can take b, but the answer to why we need this is very important, because now instead of going and iterating through every known number, or at least lakhs or millions of numbers, we can just go ahead and iterate through root of n. Similarly, we know what to iterate through for b also. Now, what I'm saying is we actually don't need both b and a values. What we can do is we can iterate through all possible values of a. We can apply that in this equation right here to get some possible value of b. Once we get a possible pair of a and b, we can go ahead and apply this in our second equation, a plus b square equal to m. And then from there also, we can solve what if this a and b is a possible pair for m. In that case, we can actually go ahead and increase a variable, maybe call it total, for example, by 1, because this will be a possible pair for this solution. Now, again, in this case, we are doing till root n. I might also ask, hello, you solve for b also. Can we use this? Definitely you can use this. You can actually go and iterate from 0 to n for b values, and then apply that into this equation again to find out possible a values, and then solve a b and then apply that in this equation again, and if that is there, you can again press 1. Now something to keep in mind here is if I iterate through all a values, I will only be iterating through square root of n, but if I iterate through the b values, I'm going to be iterating till n, which is a problem. And so by iterating through a values, I actually save a lot of time here. Now this might not be the most optimal way to iterate through this, so let's go ahead and apply the same thing to the second equation to see what the limits look like there. Okay, so here again, if I give a is equal to 0, now b will be up to root m, correct? And or if b is equal to 0, a will be up to m. So what really does matter here is if m, correct, is lesser than n. In that case, I will actually go and iterate through b values up to root m. Okay, or if n is if n is lesser than m, in that case, I will actually go ahead and iterate through a values till root n. Now this is the actual optimized way to solve this problem, and it will depend on which is lesser between m and n. Okay, because all of this is common over there. But for the sake of this question, since this is only an A tier question, it doesn't really matter. Okay, so whether you go through n or whether you go through m, I believe you will be able to solve the question either way. Okay, so we'll do both of these approaches here, and we'll start with the simple one, then we'll go on to this approach, this dual approach, and I'll show you that both cases do get passed. Okay, let's go ahead and try coding this now. If you're able to understand how you're solving this, I highly recommend as always to do this yourself. If not, let's see what this looks like in code. Let's go ahead and see what this looks like. This is the logic what I just talked about. So let's go ahead and take n and m as inputs first. So this will be list of map of int comma input dot r strip dot split. Okay, now what else do we need? We need possible a and b values for that. So let's go ahead and iterate through a values and find what b will be. Okay, so obviously we'll have a counter here and we'll set this to be 0 initially. Okay, so what is the range for a here? A is everything from 0 to square root of n included. So I'm going to take the integer value of the square root of n and do +1 to that in the range, so that because the final value of that range is not included, right, in Python, therefore I'll do a +1 over there also. So if you're looking at square root, I'll actually import this math module. So I'll do for a in range from 0 to int of math dot square root of n, because we'll deal with an integer value there because range does not work, or else then we'll do a +1, so that value is also included. Okay, from here what do I next need to do? I have to find b's value. Now if you go back to this equation, b will be given by nothing but n minus a square, correct? So b will be given by n minus a square. Okay, and then what else do we need to do? Well, we need to plug this in second equation to see if this is a valid pair. And what is the second equation? Actually, is a plus b square equal to m. So we'll say if a plus b square equal to m, we can just go ahead and increase this counter by 1. Okay, once this, or else we'll just ignore that, so we don't have to do anything in that case actually. So once this is done, we'll just go ahead and print this counter value, and you can see that all 3 test cases passed. Now this is the working code. I can actually show this to you by submitting also, and then we'll talk about the complexity of this problem and the solution. Okay, so some things to keep in mind. You can see that this will get accepted eventually. Yeah, you see that it got accepted. Okay, now if you, instead of square root of n, if you actually did n, it will still go through, and I say that because the maximum value of n only is 1000. Okay, so let's talk about some alternate solutions for this, and that is something that we talked about here, right? Not really alternate solution, but this is not exactly the most optimized solution, because in some cases the square root of m may be lesser than n, right? And that's when m is lesser than n. In that case, rather than us applying this to equation 1, we'll actually try and apply that to equation 2, and from there calculate. That will just go through less iterations for us. Okay, and so you have square root of n here, right? So rather than that, you'll replace that with m, and then replace this with equation 2. So instead of A, everything will be B, because that's just what equation 2 is, right? So instead of A, it's B in that case. So I'm going to go ahead and tell you what that looks like also. So you can just copy and paste this right here. And instead of A, I'll just put B. Instead of B, I'll put A. And then change this back and then increase the counter. Anyways, now if what I can do is here, if I say N is lesser than M, in that case, go ahead and execute this part of the code. Else, we can actually execute this part. Okay, now if I run through this, you can see all the test cases have run, but something that we're actually doing wrong here is this should not be up to square root of N, it should actually be square root of M, because that's what we'll be iterating in B's case, right? And again, this should not be N, it should be M, and this should not be N, this should be and this should not be M, and this should be N. So if I run through all that, again, all the test cases would pass. In fact, I'll go ahead and run this and show what that looks like to you also. So I'm going to paste this solution now and click the submit button. Let's go ahead and see what happens. It says running on test 8, test 26, test 35, test 38. And you can see that this code also gets accepted. So on a technical level, this approach is a bit more optimized, but it doesn't really matter because we know that the maximum values for N or M is going to be only 1000. So if you're iterating through from 0 to, I don't know, square root of 1000 would probably be somewhere, you guys can do the calculation, right? Something in the 30s, I'm assuming, right? So maximum there's only going to be 30-35 iterations anyway. So us saving costs there won't really matter, but if the values of N and M are higher, in that case, this will be the more optimal solution. Anyway, I'm going to be throwing both of these to you. Take what you want from that. Thank you so much for watching this video. If you guys do have any alternate solutions, let me know down in the comments. If you guys have any questions also, let me know down in the comments. I'll try my best to answer them. Thank you so much for watching this video. If this video helped you, hit that like button. I'll see you in another video. Until then, bye.